My name is Martina. I'm from Bauhaus-Universität, Weimar, and I wanted to say that this work would not be possible without my co-author, Wiesner. So he did actually all the work. Without him, I would not have anything to present. This was a pre-study that we did. I should have probably submitted the papers the other way around. Last week I presented a paper that built on this. So now it's the other way around. I'm sorry for that. I did not think of it. What we thought of was, well, we have all projects that have to be built. They need TAI data, tendering, awarding, and invoicing. So actually that's something that we have to do for everything we build. These can be translated into for that we need a very specific or very detailed description of the services that we want for construction later. So we could translate those into TAI specific requirements. So there we have the requirements again that we have been talking about at each conference almost every day. Our suggestion is that we could, well, the way it is right now is that best case scenario we have some tables. If not, we have some PDF files or paper-based requirements that are not really compatible with our model-based approach that we are trying to strengthen. So the idea would be to have a workflow where we can have these requirements, in this case TAI-specific requirements, input them into our modeling environment, for example, and have the output already TAI compliant. For that, we are suggesting a workflow which has mainly two steps. Step one, we take those requirements. In this case, we're still working with tables, but let's get to the outlook at some point. We would have an automated import. We would map them to the object within the modeling environment, and as they are placed, as they are modeled, it triggers again the script that's running in the background, and the requirements that are connected to a specific service are then added to the object via key table, so that we don't have to people modeling, the architects or the engineers, as we just heard, they don't need to be doing so much techie thing. They can just select a key code, and then they have all the properties and the requirements already in place. After that, in this case, we still would need some TAI application, where this model would be imported, but all the requirements would be there. This application would just be needed to add the texts. In Germany, we have very specific standardized texts for the tendering process. So that would be just a pro forma step, and we would have a phase that is usually associated with a lot of work, because having all this awarding and tendering work is actually very cumbersome, and this way we would manage to have it to shorten it, because it would also already be in the model and it would be automated in the model. Yeah, that's what I was talking about. I'm sorry. And to place this maybe on a more broad scenario. In Germany, at least, we have this guideline that you see on the left side, VDI 2552. Part 11.1, it's a very nice name. They suggest that we have employer information requirements, and from those employer information requirements we create the information delivery manual, which I forgot also has an ISO standard, right? And then from that we would create in the ISO 19650 it's called exchange information requirements, but because we have two EIRs, they changed the name to IERs to make it less confusing. But in the end, all those requirements would end up in those IERs, which are the ones we are trying to use in this project, or in this case study to make machine readable requirements, right? Around beyond that, we have some IDS and level of information need that we are not addressing in this project, simply because we try to work with Revit, because it covers 80% of the market. And therefore we use Dynamo, and Dynamo only has a sheet import. It cannot do XML. If you want to see XML, we could, future work. But in those IERs, we are including the standard server specifications for construction, which are standardized in Germany. And that's, I think, the placement. I will go into the implementation, our input data. As I said, it's a spreadsheet, so we have the different types of properties. We worked for the group drywall walls, which has a classification system in Germany, so it's very predefined which properties, which options for each property we can have. So we worked with a set of sheets where, well, if you select the key table in one sheet, then it gets the values for a drop-down menu on another table. I could explain this to you like this. That's how my students usually do it, but I will try to do it better. This is our set of scripts. Well, the first script, now I have to peek. That's where we generate the family parameter files from the shared parameter files. The shared parameters in Revit are actually quite clever. You can store shared parameters for many projects somewhere else, and no one can touch them because users usually break things. And you can apply them to family parameters. Then we select the family that they are going to be applied to, so that's the step in which we assign the properties to the object. Then in a second step, I talked at the beginning earlier about having key codes so that the assignment in Revit would be a little easier. So that when we want to model or assign, we know, for those drywalls, I will need that kind of tendering information. I don't have to assign each property individually. I can just assign a key code and a set of properties would enter. And that's how we create them. That's how the key tables are created. They are empty, and then they are populated from one of the other spreadsheets that we have. And then in the end, we enrich the tables, and we have the columns are the parameters and the rows are the properties. We also have some ancillary scripts where we allow editing so that we can clean out the scripts, the key tables, if in case we need other properties or we want to change something. We also have, we can also export the key tables because we saw the spreadsheets, because, having the information the other way around might also be useful at some point, at least for documentation. And we can also add additional parameters. We, as I said, modeled it in Revit. We used an existing project for that in Leipzig. Then we exported it using the format that is necessary for the TAI application, which in this case is I2. And so the format is CPI XML. Actually we exported an IFC, but I2 takes the IFC and translates it to CPI XML. And that's how it looks in I2. We have in row A the key tables. That's the number that users could also choose some other number. It's you can just generate it in the table and choose, I don't know, if you wanted to call it pink and red, it would probably also have worked. In the second row, in B, we have the quantity takeoff, because that's a major part of the tendering data. We need the quantity takeoff, so it's there. And in C, we see the object groups that were selected. Yes. here it's actually the D we just saw, it's the quantity takeoff, and we see on the right side of D the amounts. And in each, we just took the amounts that were calculated in Revit to see if what we exported, if there was some mistake, and it's the same. They are the same amounts. And now I get to my conclusion. So this was a case study to see how much specific requirements can be used during modeling, and if this would be, well, helpful, or if this would not make a difference in the entire process. We managed to say, to achieve it, we could make an automated TAI input of TAI requirements and also a compliant output. Our conclusion was that it was easier to handle the TAI requirements later because we already had them in the model. We managed to integrate the phases so that when we are modeling, we are already thinking about the next phase. And the phase of tendering was not so time intensive. What I want to get to, my actual conclusion, is that, well, spreadsheets, they are still not very user-friendly. If I change something in my spreadsheet, some order, I would have to redo the script, right? So in this case, we were thinking that some real structured, not semi-structured format would be more helpful, more useful. I talked before about IDS and level of information needs, so there's room for using those. We would address that with a validation of, well, with a tool that can really not just validate IDS, but really use them during modeling, because what we are doing right now is that we are giving architects, engineers, and whoever, and we are having additional management work because we define requirements, then we don't use them for a really long time, and then we check them. We just use them for checking. And people that are modeling, they are having to find out and really just prepare the data for that checking phase. And that's what I want to get to, because this process, it looks too complicated. It should be this process, right? It should be much more compact. We should just get directly from those employer information requirements to that machine-readable data that we can just import somewhere without having all those steps in between. And that should be the future work here. Those are my sources, and thank you.